So for this mathematics video presentation, I am just going to discuss about the first order separable differential equation. So here we have a given first order separable differential equation that we are going to solve. dy over dx is equal to the natural logarithm of x over e raised to y. And upon solving this first order separable differential equation, all we need to do is to find out the general solution to a first order separable differential equation or the value of y that we need to find out. By the way, I just want to include that in differential calculus, it is called first order differential equation because the highest order of the derivative is 1. And this differential equation is said to be separable because the x and the y variables can be separated. Ibig sabihin, on the left-hand side of the equation, we should have y variables, and on the right side of the equation, we should have x variables. So in order for us to separate the x and the y variables right here, all we need to do is to multiply both sides of the first order separable differential equation by the product of the multiplicative inverse of e raised to y and dx that we need to separate. And upon doing basic simplification through multiplication, the dx on the numerator and the dx on the denominator have been eliminated. That's why the remaining on the left-hand side of the equation is e raised to y dy. And on the right-hand side of the equation, the e raised to y on the numerator and the e raised to y on the denominator have been eliminated. That's why the remaining on the right-hand side of the equation is the natural logarithm of x dx. So as you can see, now that we have separated the x and the y variables, we are now able to take the indefinite integral on both sides of the differential equation. So on the left-hand side, the indefinite integral of a natural exponential function e raised to y with respect to y will give us e raised to y according to the theorem. And on the right-hand side of the equation, the indefinite integral of the natural logarithm of x with respect to x according to the theorem, that will give us x times the natural logarithm of x negative x. Don't forget to include the positive arbitrary constant c when taking the indefinite integral of a certain function. But since we are looking for the general solution to a first order separable differential equation or the value of y, we need to eliminate the base of the exponent y, which is a transcendental constant e, or the Euler's constant, which is approximately 2.718. And in order for us to do this, all we need to do is take the natural logarithm on both sides of the equation so that we will be able to apply the inverse property of natural logarithm on the left hand side of the equation so that we can eliminate the transcendental constant e. So on the left hand side of the equation, we are going to apply the inverse property of natural logarithm. By the way, the inverse property of natural logarithm is in the form of the natural logarithm of e raised to p is equal to p, or pwede ding e raised to the natural logarithm of p is equal to p. And upon applying the inverse property of natural logarithm on the left-hand side of the equation, the natural logarithm and the transcendental constant e have been eliminated. That's why the remaining on the left-hand side of the equation is y. So, ladies and gentlemen, the general solution to a first order separable differential equation is the natural logarithm of x times the natural logarithm of x negative x and the positive arbitrary constant c. And that is the general solution to a first order separable differential equation.